Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. All right, welcome to Self-Quiz 2, and thanks for coming to the end of this video series with me on logarithms. We've gone over this whole sequence here, and now it's time for the second part of the self-quiz where we talk about these exponent properties. Now, there's three that I talked about. There's logarithms of a product, and I'll just kind of keep this up here for a moment if you want to freeze the screen and maybe review that, but I did go over this in a previous video here. A product here becomes an addition problem between two logs. Make sure the logs have the same bases. Okay, that's the key there. Logarithm of a power, where the exponent becomes the front factor there. Okay, so you can move that around. And logarithm of a quotient, the quotient or the division problem becomes a subtraction problem with logarithms. All right, so if you can remember those three, here we go. Let's try these problems. 9 and 10. What you're going to do is you're going to expand these logarithms, okay, using the properties that I just showed you. Go ahead. All right, number 9, here's the answer, as you can see there. Let's kind of look at it. Everything's to the log base 6, and then we have this expression with an outside exponent. That outside exponent can be put in front. So now we have 4 log base 6 of that whole expression. 8 times 5 to the 4th. Now in this case we don't multiply it out. Okay, we leave it in exponent and expanded form here so that we can figure out a few things. And we know that this multiplication inside here, this product, turns it into an addition problem. So now it looks like this. So that 4 is actually going to be written in twice because we're just separating it out here, and we have an 8 here and a 5 to the 4th here. The final step then, of course, is to take that 4 exponent and move it to the front, and now it's 4 times 4. So that's why it becomes 16 right there, and here's our final answer. All right, number 10. Well, what we've got is this is all to the 1/2 expression, right? That's x, y, z to the 1/2 power. All right, just converting the radical there, a square root symbol, to a 1/2 fraction exponent. All right, so then we can put that in front, and you notice how this writes it as a denominator with a 2 in there. I could easily write it this way too. Let's go ahead and write it in an intermediate fashion. We have log base 5 of x plus log base 5 of y, whoops, put a 1/2 there in front, and then plus 1/2 log base 5 of z. All right, and then the final answer, at least in this software I'm using, shows it as a fraction. So there we go. Okay, so we have expanded out that expression there. All right, let's look at 2 to finish this whole video series. Numbers 11 and 12, take a look and see if you can compress or condense each expression to a single logarithm. Go ahead. Number 11. This is our answer, and we're going to kind of work backwards and see why it is. Okay, notice the pattern. These are all logs base 7s. We have an x and a y and a z, and we have 3 in the denominator, which is really 1/3. So let's write it as 1/3 in front. All right, and then we can move this 1/3 back as an exponent, so it's x to the 3rd, y to the 3rd, and x to the 1/3 power, y to the 1/3 power, z to the 1/3 power. As we remember, a 1/3 power is a cube root. So cube root of x, cube root of y, cube root of z, all the same log there, log base 7, plus those additions there make it multiplication. So we put it all together, and that's the simplified version of that whole log expression. All right, does that make sense? All right, a little review of some exponent properties there. Now, moving on, the final problem here, number 12. First of all, I noticed that this log 6, we have a 5 in front, which is going to become an exponent. 4 in front here, which is going to become an exponent on the 3. And we have subtraction. So there we go. We have 7 to the 5th power, 3 to the 4th power. They're being divided. That's a quotient because of that subtraction sign right there. Final answer, log base 6 of that. All right. Now take a look at a future video series where we'll be solving equations using what we know about logarithms and be able to go back and forth between exponential functions and logarithmic functions plus some graphing. Thanks so much for watching, and tell other people about this video series if you think it's helpful. Share it and send me a comment. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.